Hello. In this video, we've taken some test scores, and the test scores range from a 73 down this first column to a 64, here from a 71 down to an 87. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 test scores. And I've collected this data. Perhaps these are 20 test scores from a class where I gave a test, or perhaps it's a random sample of 20 scores from a larger class. The first question is, how can I easily and quickly organize this data? And the best way I can do that would be to put this data into a stem and leaf diagram. A stem and leaf diagram. So to do that, I identify the stem and the leaf. Since I have two-digit data, the stem will be the tens digit, the leaf will be the ones digit. I scan my data, and I notice the lowest scores are in the 60s, the highest are in the 90s. So I'm going to use the tens digit as my stem. 6, 7, 8, 9. Now you'll notice that that's only 4 stems, and that's going to crunch the data together. Usually it's better to have anywhere from 5 to perhaps 7 or 8 stems, so we see more discrimination in that data. So to do that, I'm going to use 2 lines per stem, like so. I'll have 2 6s, 2 7s, 2 8s, and 2 9s. Now, these are my stems, and what I'll do after each stem, I'll record the leaf. Now, the way I decide which leaves go on the first stem and which go on the second, I want to do that the way we round numbers. So if the leaf is 0 to 4, it will go on the first stem. If it's 5 to 9, it will go on the second stem. All right, so let's start, and here we go. So my first number is 73. That will go on the first stem. The next two, the 76 and 78, go on the second stem. Again, the first stem is 0 to 4, and the second is 5 through 9. I've got a 97, second line, 87, second line, 92, I've got a 75, I have an 81, an 85, I have a 76, a 72, a 62, and a 64. I have a 71, an 82. Here's a 65. I have 2 90s. I have a 76, and I have an 87. Here's my stem and leaf. And in just a few moments, I took these 20 raw scores and easily put them in a stem and leaf with 2 lines per stem. And what's really cool as I'm looking at this, because I go from low to high, I could imagine taking this stem and leaf and turning it on its side, and what I have would be the outline of a histogram for this data. Now, I'm not particularly fond of histograms because they don't show me the individual scores. I prefer that. Now, the other thing I see right away is that there's a clustering here in the 70s, and there's a clustering in the upper 80s and lower 90s. So there are two peaks to this data. There are two groups of data, those in the C's with the 70s and those with the high B's and low A's here, and the rest are stragglers. Now you're probably thinking there's certainly something we can do to improve this data. Sure there is. And let's put the data in order from left to right. So my first two stems are okay, but this should be 1, 2, 3. So let me change this. This should be 1, 2, 3. Now what's going on here? Well, so I have a 5, 3 6s, and an 8. A 5, 3 6s, and an 8. A 5, 3 6s, and an 8. The 1 and 2, 7, 5, 7 should be 5, 7, 7. And this should be 90s, then 92. And we're good. So I've put the data in order, and we always want to put our data in order. So here's my stem and leaf. Now what is really cool, now I've got 20 pieces of data. So now that I have the stem and leaf, I can easily identify what we call the 5-number summary. Okay? I'm going to identify the 5-number summary. Now those 5 numbers would be the minimum, would be the first quartile, which we label Q1. The third would be the median, the one in the middle. The median is also the second quartile. The fourth would be the third quartile, which we'll label Q3, and the fifth is the maximum. So let's find these 5 numbers for our summary. So the minimum I can see right away is 62. And the maximum I see is 97. Now the median is the score in the middle, and I have 20 numbers. So the median will fall between the 10th and 11th numbers. Well, here's the beautiful thing. I've got my numbers listed. All I have to do is count. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 76 is the 10th score, and I'll double check. I'll count 10 up from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is coming right between 76 and 78. Well, that's easy. Halfway between would be 77. And that's our median, 77. All righty. Now I want to find the first quartile. So what I'm going to do is find the median in the first 10. Now, I would never include the median when finding the first quartile, nor finding the third quartile. Well, I've got 10 scores in the top half, so the median of those 10, my first quartile, that will be between the 5th and 6th scores. So we're going to count 1, 2, 3, 4, 5. Here's my 5th score. So this number between 72 and 73 is my first quartile, and that would be 72.5. 72.5. Now I'll do the same thing to find my third quartile. I have 10 numbers in the upper half. I'll count to the fifth. 1, 2, 3, 4, 5. So halfway is 87 and 90. In between 87 and 90 is my third quartile. So 87 and 90 is 177. We'll divide that by 2. That would be 8, which is 16. Into 17 is 8, which is 16. So 88.5 will be my third quartile. This gives us our 5-number summary, and the 5-number summary can be used to do 2 important things. One, it will give us a way to check for outliers. And number 2, it will give us a way to construct a box plot. But before we do either of those, which we'll do on a later video, I want to construct what we call the interquartile range, or IQR. So to find the IQR, all I have to do is subtract the third quartile from the first quartile. So this distance, the distance between these quartiles, is called the IQR. And again, IQR stands for interquartile range. Let me write that for you. Interquartile range. And to find that, I take Q3 and I'll subtract Q1. So Q3 is 88.5. We'll subtract Q1, which is 72.5. And so my interquartile range in this set of numbers is 16. That's a measure that describes how the data are spread out, and that number will be used to check for outliers and also to construct a box plot. We'll do that in a later video.